Chapter 6, Section 5, More Quadratic Equations and Applications. In this section, what we're going to do is we're going to just basically revisit all of the solving quadratic equations. And so this section will be more like the test, I guess. In this section, you'll discover when to use which method. And again, like I said, on the test, I'm not going to tell you which method to use. You can choose whichever method you deem appropriate. So again, this is personal preference, but make life easy by remembering these tips. Number one, if the leading coefficient is 1 and the constant term is an easily factored term, then try to factor. If the leading coefficient is not 1 and the constant term is not easily factored, then do the quadratic formula. If the coefficient of the x term is even, then try the completing the square method. Now, one thing that's not mentioned on this slide is if it is not set up in standard form, in other words, if it's not ax squared plus bx plus c is equal to 0, then you can't use any of these methods, and you need to pay attention to that. So if your quadratic looks more like something like, I don't know, 2 times x plus 3 quantity squared minus 2 is equal to 5, if it looks something like that, then you should know that it's not in general form, and you're going to have to use the square root property anyway. So just remember, if it's not in general form, you need to use the square root property. If it is in general form, though, this is what I do. I try to factor it first. If it doesn't factor, then I go to the quadratic formula. And completing the square, I don't do unless I'm working in Math 112 stuff. Alright, so let's look at this one. I have x squared minus 8x minus 4. I know this will not factor because there's nothing that I can multiply together to get 4 but add together to get negative 8. This one you could complete the square because your middle coefficient b is even, so this one would be easily done by completing the square, and I think that's what I'm going to do just so that you don't forget it, and you may need to see it one more time anyway. So remember, when we complete the square, we're going to move this constant over. And so we'll have x squared minus 8x plus a blank is equal to 4 plus that same blank. And then take half of 8, which is 4, and square it, which is going to be 16. And so we're going to factor this perfect square trinomial, which will always factor into a binomial square. Match that first sign. Square root of x squared is x, and square root of 16 is 4. And then 16 and 4 is going to be 20. So now we'll take the square root of both sides. And we'll get x minus 4 is equal to plus or minus the square root of 20 is going to break down into 2 square roots of 5. Add 4 to both sides. And you're going to get x is equal to 4 plus or minus 2 square root of 5. And this is some decimal, and there are 2 answers there. You can put it in your calculator to get the decimal, but I don't want you to do it on the test, but I'm saying if you graph it in 112, you'll need those decimal forms. So in your calculator, you would just do 4 plus 2 times the square root of 5, and then 4 minus 2 square root of 5. Alright, this next one, my leading coefficient's not 1. I can factor it, but I'm not going to. I think it is factorable, but again, I'm not going to do that because a lot of people don't like to factor. So I think I'm going to use the quadratic formula on this one. So I'm going to say x is equal to the opposite of b. So b is negative 2. So in your formula, it's going to be a positive 2. So x is equal to the opposite of b plus or minus the square root of negative 2 squared minus 4 times a times c. All over, don't forget that denominator, 2 times a. So we're going to have x is equal to 2 plus or minus the square root. Negative 2 squared is going to be 4. Negative 4 times 3 times 1 is going to be negative 12. All over 6. And then you'll have 2 plus or minus the square root of negative 8, and that tells me that it would not factor. So even if I tried to factor, it would not factor because of the negative underneath the radical tells me that I'm going to have a complex fraction. And so we'll have 2 plus or minus the square root of negative 8. I know that an I is going to come out, and I know there's a 4 in there, so a 2 is going to come out. and then a 2 is going to stay under, over 6. And then from here we would just reduce everything by 2, so this is going to go to 1, this is going to go to 1, and this is going to go to 3. And remember how we discussed when to write a 1 and when not to write a 1? The leading 1 is a constant, so we do need that. The next one is a coefficient, so I don't necessarily need that. You can write it if you want to, but you don't necessarily need it. And so that's your answer. And just so you know, again, this is 112 stuff, but here you do have an x-intercept. So this parabola, when you graph it in 112, this will have x-intercepts and it will cross the x-axis. However, when you get a complex number, an imaginary number, that just means that it's still graphable, it's still a parabola, but it's not going to cross the x-axis. It doesn't have any x-intercepts. Okay, and this is what I was talking about earlier. This is not in your general form. This is not ax squared plus bx plus c is equal to 0. But what we need to do is we need to get it into this form, and we're going to use our Chapter 4 techniques for solving equations that have fractions in them. So we're going to multiply 3 by the common denominator, which is going to be 3n. And so when I do that, 3n times n is going to be 3n squared. And 3n times negative 2 over n, the n's cancel out and I get negative 6, is equal to 3n times negative 7/3, the 3's cancel out and I get negative 7n. So I'm going to get it set equal to 0, so I'm going to add 7n to both sides. There's no like terms over here, so we're just going to write it in standard form. So you have 3n squared, or general form, 3n squared plus 7n minus 6 is equal to 0. Okay, and again, I'm going to use the quadratic formula because my leading coefficient is not 1. So we're going to have x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we'll have x is equal to negative 7 plus or minus the square root. 7 squared is 49. Negative 4 times 3 times negative 6 is going to be positive 72, I think. Yes. So we'll get plus 72. All over 2 times 3 is going to be 6. So we'll have x is equal to negative 7 plus or minus the square root of 49 and 72 is going to be 121 over 6. So x is equal to negative 7 plus or minus 11 over 6. And again, like I showed you in earlier sections, you can break this up. So we'll have negative 7 plus 11 over 6 and negative 7 minus 11 over 6. That plus or minus sign goes to that 11. So you'll have negative 7 and 11 is going to be 4 over 6, which is going to be 2/3. And then this one is going to be 18, negative 18 over 6, which is going to be negative 3. And so these are your two answers. And because I got these whole number, or not the whole number, but because I got these numbers here, I know that this would have factored. But again, if the leading coefficient is not 1, then I'm going to use the quadratic formula instead of factoring. Okay, so here is an applied problem. I know y'all love these word problems. Find two consecutive odd whole numbers such that the sum of their squares is 290. Find two consecutive odd numbers. So remember, for odd numbers you have your first number, and then for odd you have n plus 2. So find two consecutive odd numbers, two consecutive odd whole numbers, such that the sum of their squares is equal to 290. 290. Alright, so let's do this. We have n squared plus, this one's going to be n squared plus 4n plus 4. You're going to have to full that out. Is equal to 290. And then we'll minus 290 from both sides. And so n squared plus n squared is going to be 2n squared plus 4n, and then 4 minus 290 is going to be a negative 286 is equal to 0. Alright, so I'm going to do the quadratic formula on this one. Actually, if you wanted to divide everything by 2, you could. It's not necessary, but You still could. We have n squared plus 2n minus 143 is equal to 0. I don't know if there's something that you can multiply together to get negative 143, but add together to get 2. So I can't do that off the top of my head. So I'm just going to use the quadratic formula. So we're going to have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that is a 3, as ugly as it seems. There we go. Alright, so we have x equals negative 2 plus or minus the square root of 4 plus 4 times 1 times 143, 572. Goodness. Over 2. And so we'll have x is equal to negative 2 plus or minus the square root of 572 plus 4 is 576. And I wonder if I can take the square root of that. I can and get 24. So we'll have negative 2 plus or minus 24 over 2. So that tells me that it would have factored. I just didn't want to take the time to figure it out. So negative 2 plus 24 over 2 and negative 2 minus 24 over 2. So up here, negative 2 plus 24 over 2, that's going to be what, 11? And here, negative 2 minus 24 is negative 26, so that's going to be negative 13. So there's your two answers. Alright, here, a number is equal to the square root of the sum of the number and 6. What is the number? A number is equal to the square root of the sum of the number and 6. So that's going to be n plus 6. What is the number? Well, let's square both sides. So we're going to have n squared is equal to n plus 6. And then move everything to one side. So we'll have n squared minus n minus 6 is equal to 0. This will factor pretty easily. So we'll have n minus 3 and n plus 2. So we're going to have n is equal to 3 and n is equal to negative 2. So there's your two numbers. Alright, so I would like you to complete 1 through 21 odd on our and 41 on page 328. Bring them into class if you have any problems, and just remember you can use any method that you want to in order to solve these, and also remember that if it's not in general form, you need to get it in general form before you use these methods.